Dexter Moren is an architect, CEO of Dexter Moren Associates, an architect and interior design firm based in London. So over to you, Dexter.
It's a pleasure to be here and be part of this new initiative that Venture put forward, and it's been exciting to hear what's been to date. But the interesting thing I find about the three of us is we were all born in Africa. We've all gone to the UK and done some studying, and we've gone to America and worked and studied, and yet we're back here in the sense because of our passion for Africa. And Esther is currently Associate Professor of Engineering Design and Architectural Engineering at Penn State University, and describes herself as somebody who bridges across the issues of sustainable materials, intelligent systems and entrepreneurship. And in the time I spent with her yesterday, I was fascinated with all the skills that she has and all the wonderful things that she's doing in places like Philippines as well as in Africa. She's also director for Penn State Uni of the Food, Energy, Water Nexus for East Africa. And I hope maybe she'll talk a little bit about that. Nick is an investment banker. And he has taken on the giant step of moving into Africa. Again, the company he represents called International Green Structures. And I think what excites me most about this session, hopefully, which will be slightly different from what we've talked about before, is we really want to focus on local. And as Matt has said to you, I'm an architect. I do most of my work in the hospitality space, which is quite spread out. Esther, on this issue of evaluating available and how to source sustainable materials, can you talk a little bit about your kind of experiences?
Okay, thank you very much, Dexter. One of the things that I started doing when I went to the US is looking at sustainable bricks. My PhD was actually in intelligent systems and data mining, but then I tell people that the data and the knowledge is only useful if you can apply it to something really practical, and bricks was an interesting case study. So, and some interesting numbers, I think better with numbers. We have 300,000 brick kilns that are firing bricks across the world every year, and these 300,000 kilns produce about 1,500 billion bricks every year. Only 10% are based on modern technologies. Yeah, a lot of them are being done in small-scale rural kilns. A lot of that you see that when you travel in Kenya or even Tanzania. And some other interesting numbers, we know that as far as black carbon is concerned, brick production is one of the three industries that's producing 22% of the total volume of black carbon, and brick production is actually number one. Yeah, so for part of my work, I look at ways of finding alternative materials. But then at the same time, I'm also embracing this brick production, saying, you know, it's huge, it's not going to change anytime soon. And also we know that people like bricks because they are durable, they have good moisture-resistant properties. Architects love them because they can be used for aesthetic functions. So they are there, and we are going to live with them for a very long time. So I'm partnering with people in material science who tell me that they do things at the thickness of the human hair. And I tell them that, you know, you do things, rocket science, ceramics. Brick production is a little more simpler, yeah? So we are working together trying to see if there are ways that we can look at these low-tech brick kilns where the bricks are being produced in large volumes across the globe, and also in Kenya and Tanzania where I've done a lot of the work for my work, and see if we can try to lower the firing temperature and also shorten the duration. And if we do this, we are bringing the sourcing of the material very, very close. Sometimes even at the site where this is being done, because in Tanzania, a lot of people told me that when they are firing the bricks, they will source the soil from the construction site because there's excavation work that's done for the foundation and there's soil that they have to pay someone to cut away. So they say, we can work with this. Yeah, so that's one example that I would like to start with.
I think what was interesting when we spoke, how science is perhaps being able to provide additives that make those bricks more efficient. And maybe you could just allude a little bit more about that.
Give you an example from Tanzania. I was talking and working with some architects, and they told me certain things about the soil property. They said that the clay content was X. And I asked them, how did you determine this? They say that they use rules of thumbs. So I got fascinated. We know that I have access to state-of-art laboratory facilities. So we brought back some of the soil and we characterized it at the microstructure level, like breaking it down to the molecules and the atoms and everything. And lo and behold, the soil did not have as much clay as they were assuming. So part of the moisture issues that we were seeing on the walls that were deteriorating rapidly and therefore affecting the rate at which these materials are being used, because when people see materials damaging rapidly, they're like, I want concrete. Yeah, we realize that it's because of the rules of thumb. It's because soil properties are not fixed. They can change because of very many different reasons. However, the good news is, if we know what is lacking, if we know the composition of the soil, we can add stabilizers, we can add supplementary materials if the need is to increase hydration, etc. And for a place which is along the coast of East Africa, they already have very good traditional precedents of using lime. Yeah, for the soil that we looked at, all they needed to do was add lime. I also learned that there are certain parts of the world where the soil properties can be improved by using horse urine. Yeah? And my students and I wanted to experiment with that, but then the university got a little bit too concerned, and the cows were supposed to wear catheters, and we're like, okay, we're not doing this. We're like, the cows are peeing, we just want to put a bucket. They were like, no. But I understand that the urine, horse urine, has some properties that work very well with certain types of soil.
And maybe, Nick, you can tell us about your technology and how that's changing opportunities.
Yeah, I think what's interesting with bricks made from soil is just if you date it back maybe 6,000 years ago, when the Egyptians were building, they used soil and straw. And some of those buildings are still standing today. So it's a question of us understanding our resources and how to use them. So we've made huge advances in the buildings that we see today with wood, with cement, with concrete, polystyrene, etc. But what we wanted to do was bring back an old technology that was initially used after World War II to rebuild a lot of the buildings throughout Europe. It was an initiative by the UK government to basically take large straw bales, compress them into building panels. And so the buildings that were built in the 1940s, a lot of them are still standing today. And so what's interesting about using straw is that if you go to a country, so for example like Kenya, if we are producing wheat or rice, which are staple foods in most countries, we have a raw material. And so when the farms go to harvest the wheat or the rice, what's left is the stalk. It's the straw stalk. And a farmer will have to clear that one way or the other in order to plant for the next season. So it's a waste material. In Egypt, for example, a lot of their carbon emissions come from the fact that they burn the straw to clear the fields. And it's just immense. And Egypt has a huge amount of straw that they grow, wheat straw, throughout the year. So rather than do that, we can collect the straw, bale it, and put it through a machine and process into building panels. Nice thing about the process is that we use high temperatures and high compression. So when we heat it to about 400 degrees Celsius, and that's the process. The reason we use wheat and rice is because there's a lignin inside the straw. When heated, it acts as a chemical bond, so we don't have to put any binding agents, we don't have to add glue. So pretty much our local raw materials all just sourced in Kenya. We don't need to bring materials in from another country. And that's been a huge hit with some of the government projects that they're looking to do. Is that they're saying, well, hey, not only are we adding to the agricultural field, we're also adding to the housing field, and we're not importing anything. I mean, it's a great industry for Kenya. There are bits and pieces we still have to import, like steel. We don't have locally made. So it's not that, but 90% of our building process is locally manufactured, locally sourced. And that's now where it comes to the sustainability and renewability of materials. Like what Esther went into about the carbon emissions when it comes to cement, concrete, 22 to 30% of the global pollution. What we're doing is really just clearing land. Clearing land that farmers are growing anyway. And the wheat straw and rice straw doesn't have any nutritional value to animals. In order for an animal to eat it, they're going to have to mix it with molasses or something like that. So it really is just a waste material. And so that's the sustainable and renewable side of it. In that in Kenya, we're blessed. We have 2 seasons of wheat. So we can pretty much harvest throughout the year. And that's the sustainability of it, is that it's growing anyway. We're not taking from an industry that would otherwise use it for something else. There's a reason why you put straw at the bottom of a barn for cows to sleep on. They don't eat it. It just has no value. The termites don't attack it. I mean, it's something I'm surprised went dormant for so long. But yeah, we're trying to experiment with it and see something new and see a new way forward.
I mean, I think I'm excited by the fact that these are local, sustainable materials, and they kind of go back to the traditions. And we all know we love visiting the buildings of the past that have stood for years and are wonderful, and they also have a propensity, because they've developed over years, to actually deal with climate in a good way. I mean, Prashant talked earlier about the importance of orientation of buildings and of shading and all those sort of things. And I think a lot of architecture has kind of lost out in terms of learning from the past and those traditions. But when we spoke last night, Nick, I was enthused by where you're taking this technology in the sense of providing fairly low-cost housing within Kenya. Perhaps you can talk a little bit about that.
So what we've tried to do is to introduce the material in the market where it sits well within the low-income sectors, where so we've already done some projects in places like Kawangware, in other slum areas, to rebuild the mabati, the tin, the iron sheets with the wood, which are highly flammable. It's really not a dignified sort of structure to live in, the way that they're done, because they're rusted. When it's cold, it's freezing inside. When it's hot, it's boiling inside. And so what we're doing is we're trying to position this as a tool to help investors get into those markets, knowing that there's peace of mind that the building's not going to collapse, it's not going to burn. You have all those safety features. It's KEBS approved, it's internationally tested, it's international building code, everything in between. But it's priced in the market that actually sits well within the low-income sectors. So what we're starting is different initiatives to do maybe 1/8 of an acre or 1/4 acre in these areas, do a lease, build some low-income housing, some bed sitters or single rooms for rent. And so to the investor, the returns are actually really good. They're obviously not as good as Mabati or anything like that, but given where our treasury bills sit and everything at around 11 to 14% is the interest rates that you might get in the market. If you're getting 20 to 25% after tax, I'm trying to position it in a way that makes sense to investors. And I feel that the product also makes sense to the consumers, and that we're not building something that's substandard. We're building something that has high quality standards, that's been used by the UK government, by other governments. It's been used all over the world, and we just feel that there's been something missing in the market. The other thing that is very apparent, the other way to go is to build mud huts, because you can't get anything really more affordable than that. If you get a crack in it, scoop it up, swipe it on the side. I mean, but how do you do that in a way that moves forward, that's formalized, that's recognized? And so I think that's where Esther was.
I was going to ask that. I mean, maybe Esther wants to answer this first, but do you see any regulatory kind of blockages in terms of certification of going back to the traditions?
With the earthen materials, I got interested in it actually largely because of the social stigma. My starting point for this line of work was Tanzania, and I'm thankful for that. So since 2008, I've been working in research and development with earthen masonry, partly in Kenya, but mostly with the National Housing Building Research Agency in Tanzania, and their role is to promote the uptake of affordable and more sustainable building technologies. And we did realize that there is a social acceptance problem, but there's also a bit that the building codes can play to promote the uptake of these materials. This is a problem universally, even in the US, that changing the building codes is a relatively speaking lengthy process. And for us to initiate a change in the building code that will allow a break from the conventional building materials, we need a lot of empirical data. So this is where the community that I work in we come in to help with this. We can generate data rapidly. So remember I mentioned doing things at the scale of the material science world. We have very reliable ways of synthesizing materials in a laboratory at a very, very small scale and then growing it, like scaling up the scale of production from the microstructure all the way to the real size of a building. It's a process, it's a research and development process, and the commercialization happens at the very end. But for us to influence the building codes, whether it's through international building code agencies or through policy change, we will need data. We're generating data, and we just need to keep generating data to show that the material can withstand the conditions that it's being subjected to. One of the things that I did with my group, I was at the University of Florida for 10 years, and it's hot and humid. And we also are like hurricane headquarters central. We get a lot of hurricane. So we decided to prove that the material that we had engineered that was earth and masonry, so it's a hybrid. We are mixing the old with some of the knowledge of modern technology, and we are able to prove that it can withstand the hurricane conditions, not the extreme ones, but even for the extreme ones, no building will withstand. Yeah, but where the threshold is for United States, for Florida, we were able to show that if we combine the new scientific knowledge on how to design things at the microstructure level with ancient technology, we can satisfy the building code requirements. And then the second point related to this, I mentioned social stigma. So a lot of the efforts that have been there before me have realized that by labeling the material as a cheap material, yeah, there are parts of the world where you go and you interact with people. So again, I'll make reference to Tanzania, where I spent a lot of time, that you show up, and even the poor person, we see them doing fascinating things, that they have a material for the wall that is more conducive for the local climatic conditions, hot and humid, no air conditioning. But then they are beginning to build a perimeter wall with concrete. And this process could take 10 years, 20 years, but they totally are determined that they're going to do it. And once they're done, they will knock down the sustainable walling that is actually better. So you go inside the concrete houses. I went inside some of them, and they're hot and unbearable. And I'm like, why did you knock down the wall? And it's a stigma. Yeah, they're saying my house is a label for my poverty. And I know I'm poor, but I don't want to be labeled. So we are increasingly, so trying to encourage people who are in the other income brackets to embrace this material because it's the right thing to do for the environment. And if we can get more of them doing this, then the stigma will go away.
Do you have LEED certification or EDGE certification on this?
No, we've primarily just gone for the Kemps Standard. We've joined John over here with the Kenya Green Building Society. So I think there's still progress and things that we can apply for and go forward with that. Initially, we really just set out to manufacture panels. But to get into the market, we had to demonstrate that they work, demonstrate to people how they work, and spend money to get into that market. So we're in that process of learning the different certifications now that we're sort of growing out of just strictly a manufacturing mode and more into a development or investment mode. But I think I met some people here yesterday that I think I'll be having very good conversations with about that as we move forward for 2018.
At this point, are there some questions from the audience?
I was just wondering, how in the room, possibly, how this discussion of using what is an abundance of resource here, but with limitations of manufacturing, and how that plays a part.
I reckon we probably have enough wheat straw to run 4 machines, which would generate something like 100,000 panels each machine. So we could do about 400,000 panels, depending on the different housing sizes. That's about 10 to 20,000 houses. So it's not a total solution. Each country has its limitations as to how much is grown. A country like the United States or Australia, I don't think we'd ever run out of material for a factory. But, there's machines in Rwanda, there's machines in Uganda. Rwanda actually has to ship in straw from Kenya. So there are limitations when it comes to the raw materials. So obviously now going back to the capital investment side is you want to make sure you're generating, you have enough to generate enough panels to make sales and to make that profit margin and to do well. And if if you don't check off all those boxes to each country that we're investigating, it's sort of a non-starter. So I wouldn't really look to, if we're going to start tackling 100,000 houses a year or even 200,000, it's going to be a collective effort on all different kinds of materials. We're going to have to use the compressed earth blocks. We're going to have to use traditional buildings. We're going to have to look at alternatives such as engineered polystyrene. They're all necessary if we want to tackle the housing market. But what I do find, based on sort of my background, is that a lot of money went towards the high-end stuff. So there was sort of a push away from the manufacture of affordable and sustainable housing. So it's about trying to bring that back and doing it in a responsible way. And so that would be where I see limitations, is just how much you can produce in a year. And even more so having the demand to produce that much, because it's not an easy or a cheap endeavor to get into.
Mm-hmm. So with the bricks, especially the fired bricks, the problem is not the capacity to produce. It's more actually on the demand side, that as long as the designers are specifying or other building materials, there's limited capacity to produce. Because for us, remember I mentioned that we have just 10% of the 300,000 kilns worldwide using modern technologies. The technology is there. The problem is there is not enough awareness in the market, or at least maybe from an owner perspective, because the owner largely controls what's going to go and not go in the market. But as designers and builders, we can have these conversations with them and try to sensitize them on the value of doing this, because it's good for the environment, and then at the same time, it creates job opportunities, etc. He mentioned at the start that part of what we do in engineering design is look at the system, the entire system, meaning we are interested in the entrepreneurial side of things, looking at the space, the opportunities for commercialization. So I can say for a fact that from a materials perspective, so my university has an initiative that a group of us formed, it's called Humanitarian Materials. All we're looking for is the demand. Yeah? If you tell us that there is a demand for 100,000 houses, I have people who I work with who are dying to sink their teeth into that kind of thing. However, before we can make a huge investment in the capital, the kind of equipment and machinery that's going to require that, we have to know that the market has an appetite for this kind of thing. It has to be demand driven. Yeah, the people in the room are the ones to initiate these discussions, encourage the owners, encourage the developers to consider this material. And like Nick, I agree. I don't think it's a matter of displacing or getting rid of certain materials. Yeah, we need all the materials because it has to be a portfolio approach. So it's just a matter of sitting down and seeing how do we develop this ecosystem where certain buildings are going to be made of very high-tech, very modern materials, and then certain buildings are going to have hybrid solutions. And then if you're talking about my grandmother's one-bedroom house in the village, low-tech. And I think one presentation yesterday, the numbers we were given, we were told that even though we are urbanizing at a very rapid rate, the urban population at this particular point is still less than 30%. So there's a huge volume of houses that are being constructed across the country. Yeah, the need is not adequately met even out there.
Even to the same extent as what she was saying about the volume of houses, it's really in the informal sector that we don't really count. I mean, go anywhere where there's development and you're going to have iron sheet and wooden houses coming up every day, every single day. Markets, kiosks, everything, which really isn't being included into the formal count of what's actually being built. So the question is how do we address it as manufacturers, or how do we get into that market? Because the guys who have the rolling mills are making a killing. I mean, and it's not an approved building material, but they don't sell it as a building material. But it's the world over. Yeah. You go to any slum, that's what they build with. And so it's just how do we integrate a new system or introduce a new system?
And then to add to what you're saying, so remember we all know that there are 3 pillars for sustainability, and there's the social. So the question is, what is our responsibility as people in the formal sector to the social issues that we're dealing with? Yeah, because we know that the problems in places like Kibera, the swamps, the slums, not the swamp. The swamp is in Florida where I was, but in the slums, we know that the inadequate housing conditions and everything that's going on there has a direct effect on us. If cholera breaks out there because of the housing conditions, lack of infrastructure, we're all going to get affected, and we actually do get affected. We know that the problem with Ebola, yeah, it became a worldwide problem largely because of inadequate housing. So I would like us to think actually more in terms of it's the right thing for us to do, to embrace the informal sector, not just because there's an entire economy that's revolving around it, but because we are not divorced from them. Things that are happening there can have a direct impact on us very, very quickly.
I mean, we all have the perception, listening here, that we're talking about domestic scale. Is there anywhere where you see these technologies being involved in some of the bigger commercial buildings?
Absolutely. Yeah, absolutely. We've already gotten into some high-end buildings as well. We did a retrofit in Old Mutual building in town. Guy was building a spa. It's turning out quite nice. Coffee shops, all sorts of high-end stuff, but because it can be done in a matter of days. I mean, the retrofit in town took us 6 days. So it saved the guy a lot of time. It put him into a revenue position very quickly. So because there's already such a developed high-end market here in Kenya where you can go and buy apartments for 30, 40 million, you got properties in Karen selling for 300, 400 million, you're spoiled for choice in that sector. But because land prices and infrastructure and everything's just risen so rapidly, it's priced most of us out of the market, especially as investors. 3% return's not interesting. I'd rather put it into a treasury bill. So what I'm starting to find a shift towards these materials is that the returns are good. And I think investors are starting to click onto that, saying, well, you know what? If it meets all the building standards, why not use that? If it's going to give us a better bottom line and we get green certification and everything else in between. This is what's interesting about the material I work with, is that it can go into the high-end products as well as be suitable for the low income.
I mean, obviously it's not structural.
It's not structural. Well, it's not load-bearing.
Right,
Yeah.
I beg your pardon, the correction.
So the one I work with is load-bearing, and I increasingly use the word hybrid because I don't think it's either this or this. I think we can bring these two together, and I'll just say very, very quickly, the team that I talked about, Humanitarian Materials, we are very interested in exploring opportunities that allow us to start to work with 3D printing. Yeah, so if there was a demand for using local material as the input into 3D printing, my Humanitarian Materials team would go crazy.
That's a good note to finish on, frankly. Unless there's some more questions.
So the traditional materials and the ways of using them are understood by people at kind of a grassroots level. If these materials that you're developing now are using traditional materials but are now unfamiliar to the people who should be using them, so the construction method becomes, this is kind of the hybrid. Have you started looking at the education requirements or how to introduce these new materials so that they can become part of a culture of using them that's not requiring consultants to help design a building?
Ideally, yeah. I think there's a lot of training and a lot of education that will need to be done. So we're going to have to raise capital for the budgets to do all that training. So right now what we're doing is working with, just to give you an example, when we were building in Kawangware, we selected a local contractor near to the area and did training with him, taught him how to build with the product. And he actually used casual laborers who lived on the property that was being built. And so those guys were getting informal training in how to work with these materials. And there's actually quite a number of people now that we can call upon who know how to handle the materials, how to construct the building. Don't get me wrong, we still have to have an NCC contractor on site, sort of directing everything. But because one panel is only about 60 kilos, so a couple of guys, we build everything with about 4 or 5 guys. So it's now about getting them to transfer the knowledge into those areas, and that's where I found it probably will be the most impact, will be in these low-income areas such as Kawangware or those areas where not only are the informal sector getting training, as casual laborers. You know, eventually, as the contractors grow and start to want to work with the material more often, these guys are also going to start finding themselves more employable as we start to educate people on this product. And what was interesting is how easily, I didn't expect it, but how welcome my clients in those areas, it wasn't even a second question. They said, will it burn? No. How quickly can you build it? Okay. How much does it cost? Okay. All right. That's it. They pull out the cash from some hidden stash, and they're ready to go. And that was a bit more of a surprise. I didn't think it would be welcomed that quickly, that straw could be used to build a house that people would be confident in. We have such a strong mentality in Kenya for brick and mortar. And so it's about, like you said, it's more training, more projects, and more contractors getting on board with the technology.
And I'll just add very quickly, I have to add this because I wear many hats, including being a professor, I teach. So in the institutions that I've been affiliated with, and I've spent a few months even at the University of Nairobi, I know I'm not the only one. We do create opportunities for sharing this information with the students, and they're very, very interested. I know that my students at Penn State University or students at the University of Florida have more opportunities than the students here. So my challenge to the people in the room is, if the industry demands it, the university will teach it. Yeah, it's supply and demand. So embrace the university, engage with them in dialogues, instead of having conversations that these students are not doing what we want them to do, or they don't have the awareness that we want them to have to embrace the use of sustainable building technologies. Go to the university, and have dialogue with them and say, this is the sort of skill sets that we're looking for. This is the sort of knowledge that we're looking for in the future workforce. So
we've been in talks with several universities from Nairobi to Kisumu about doing student housing out of this material there, and the students learning. I mean, there's a whole process. So if you're working with schools and universities that have a background in architecture or engineering, I mean, what better way to have the students build their own housing and learn the process as part of a curriculum? So, yeah.
What I leave this room with from this panel is that we can look back at traditional materials, and we can use new technologies to embrace those materials and using excess leftover products from the fields and enhancing the basic brick with the technology we have today, rather than inventing something new that has to come from China or wherever. And I think that's incredibly exciting, because that has to be the ultimate sustainable future.